When we talk about rates and ratios, we're looking at applications of our fractions knowledge. A ratio shows the relative sizes or magnitude of two or more values. It is a comparison using division. Fractions are representations of division, so therefore ratios and rates are representations of division. There are three different ways that you often will see a ratio represented. Let's look at the ratio of oranges to apples. First off, the order matters. We're looking at oranges to apples. There's 4 oranges and 2 apples. So as a fraction, we read it numerator to denominator. So this would be 4 oranges to 2 apples. As with any fraction, we need to simplify it down. This would be 2 to 1. It is a 2 to 1 ratio. Odds notation is just another way of representing the fraction version of a ratio. Instead of reading it numerator to denominator, we would read it from left to right. So now we have a 2 to 1 ratio. Again, that would be a 2 to 1 ratio. Notice that both the colon in odds notation and the fraction bar in fraction, they represent the word 2 when we're reading a ratio. To represent it as a percentage, we need to think back to our knowledge of percentages and fractions. I could set up a proportion, or I could divide things straight out and then turn a decimal into a percent. We'll use the shortcut instead of using the proportion method. So I'd look at my fraction, 2 over 1. I would take 2 divided by 1 equals 2. That's my decimal, so that's my value. I need to move it 2 places over to turn a decimal into a percent. 1, 2 place values, because what we're really doing here is multiplying by 100, so I have a 200% ratio. On your own, switch things around. Find the fraction, odds notation, and percentage representation of the ratio of apples to oranges. Compare the first 3 answers we did and the second 3 that you're going to try. Ask yourself the question, are these ratios the same? How do you know? We're dealing with the same values, but the order has changed. Ratios are a very real-world applied use of fractions, so you'll see them pop up more in word problems or situation-based questions. Recipes, especially baking, have a lot to do with proportions and ratios. If the ingredients don't stay within the same ratio, the flavor will not come out the same, or the cookie will be harder or softer or drier. Because we'll be dealing with more word problems in this unit, it's very helpful to try to express or describe these rates in words. Just like in English class, if you're trying to understand a scenario, summarizing it in your own words helps. So if we look at this first example, what is the ratio of chocolate chips to flour? Well, I can look. In my recipe, it calls for 4 cups of chocolate chips. It calls for 6 cups of flour. The order matters. So if I had to write this out in words, it would be 4 cups of chocolate chips to 6 cups of flour. This rewords the question so I can understand it better, plus it sets my numbers up in the right order. 4 cups of chocolate chips to 6 cups of flour as a fraction would be 4 to 6. If I simplify that down, my fraction is 2 to 3. It's a 2 to 3 ratio. Going from fractions to odd notation, we're just turning it on its side. 2 to 3. To make a percentage, I can use my shortcut, 2 divided by 3 in my calculator, and either multiply by 100 or move that decimal 2 place values over to the right, and we get 66.7%. In our next example, what is the ratio of flour to sugar? Well, we have 6 cups of flour, the recipe calls for, and 3 cups of sugar. So I want to describe that. I want to reword it to make sure that I understand the entire situation. So I would say there's 6 cups of flour to 3 cups of sugar. So for every 6 cups of flour, I need 3 cups of sugar to keep my recipe within the right ratios. I understand the situation a little bit better, plus I have my numbers written out in order. This is a ratio of 6 to 3. If I simplify that down, that's a 2 to 1 ratio. I take my fraction, I turn it on its side, now it's an odds notation, 2 to 1 ratio. I can take my fraction and turn it into a percentage. 2 divided by 1 is 2, multiply that by 100 to get 200%. On your own, try the next 2 examples. Write out the ratio in words, represented as a fraction, in odds notation, and as a percent. In order to prepare for tomorrow's activity, please fill out this small questionnaire. Tomorrow we'll review ratios in relation to your shoe size, age, number of siblings, number of pets, and the number of states that you've visited compared to a partner. Comparing ratios is like watching two different people talk. If they speak different languages, that doesn't make a lot of sense. If they're speaking the same language, they both can communicate, and you can understand what each one's saying or represents. In order to get our ratios to speak the same language, so to speak, we need to find common denominators. In order to compare ratios, you need common denominators. They're the key. This will require us to tap back into those fraction skills. Step 1, when I'm given two ratios, in order to compare them, I need to find the LCD, the lowest common denominator. In order to do that, I'm going to list out my multiples. It's like skip counting. So for 8, it's 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32. I'll do the same thing with 12. 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36. I want to find the smallest number, the first number that pops up in the list of multiples like that. In this case, it's 24. Now that I know what my final denominator needs to be, I need to make equivalent fractions with this new denominator. You can either set up a proportion with 24 as the new denominator and cross multiply, or if we look at the multiples of 8, 24 is the third multiple. So I'm going to multiply top and bottom by 3. Same thing with 12. 24 is the second multiple, so I can multiply top and bottom, my numerator and denominator, of the ratio that has a denominator of 12 by 2. When I multiply those, I get 9 24ths and 6 24ths. Compare the ratios by looking at the biggest or smallest numerator. It all depends on which one they're asking for. This question asks which is the smaller ratio. So 6 to 24 is a smaller ratio. If it asks what's the bigger ratio, we would have 9 24ths as the bigger ratio. Which ratio is smaller, 1 to 6 or 5 to 18? We start by finding common denominators, so the lowest common denominator. I'm going to multiply out my multiples of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. Same thing, I'm going to find my multiples of 18. 18 times 1 is 30, or is 18. 18 times 2 is 36. I see 18 in both lists. I don't have to do anything for my ratio of 5 to 18, but my 1 to 6, because 18 is the third multiple in that list, I'm going to multiply my numerator and denominator by 3. Other side, I don't have to do anything, but it's really thinking like multiplying by 1. Find my equivalent fractions, and then I just have to compare the numerators. I'm looking for the smaller ratio, so the smaller numerator is my answer. In this case, the ratio of 1 to 6, or its equivalent 3 to 18, is the smaller ratio. We'll have you try the next two questions and then answer the think, pair, share question. Do you need to have lowest common denominators in order to compare ratios? Another way to compare two ratios is to make a percentage out of each. Since ratios are just fractions, we know how to turn a fraction into a percentage. We've already discussed how in order to compare ratios, you need common denominators. We also know percentages all have denominators of 100. So if you turn your ratio into a percentage, you're automatically creating a common denominator of 100 every single time. We start this process by turning each ratio into a percentage. There are two different ways to turn a fraction into a percent. We can either set up a proportion with 100 as our denominator and an unknown or variable as my numerator. We cross multiply. 100 times 5 is 500. Divide by the third value, so the denominator we already started with. So 500 divided by 17 gives me 29.4%. If you use this method, it automatically comes out as a percentage. There's a more calculator-driven method. So we could just divide 8 divided by 37 in a calculator. That gives us a decimal answer. So I need to turn that into a percentage by either multiplying by 100 or moving the decimal place to place values. So we get 21.6 as a percentage. Once we have both ratios represented as percentages, we just compare the ratios by looking at the biggest or smallest percentage. In this case, they're asking which ratio is bigger. 29.4% is bigger, so that means the ratio of 5 to 17 is the bigger ratio. Let's apply this same method to the ratios of 3 to 7 and 32 to 56. We want to find which ratio is smaller. I'm going to apply the calculator method, so I'm just going to take my first ratio, 3 to 7, and divide 3 divided by 7 to get a decimal of 0.428. Shortcut is move the decimal 2 places to the right because we're multiplying by 100. I'm going to get 42.8%. Do the same thing with my second ratio. 32 divided by 56 gives me 0.571. I'm going to multiply by 100 or move my decimal 2 place values to the right. That's going to give me 57.1%. They're looking for the smaller ratio. The smaller percent, 42.8%, belongs to 3 to 7. So 3 to 7 is the smaller ratio. 32 to 56 is the bigger or greater ratio. On your own, try the last two problems.